Imagine traveling to distant stars faster than light. This is the dream of science fiction, made possible by warp drives. They are often seen in movies and TV shows like Star Trek. Warp drives allow spaceships to travel vast distances quickly, but how do they really work? Is it just fantasy, or could it be a reality? Warp drives are not about moving faster than light through space. Instead, they are about bending space itself. Think of it like this: fold a piece of paper in half. Now imagine the paper represents space. A warp drive would be like folding the paper, bringing two distant points closer. This bending of space is key to understanding warp drives. It allows a spacecraft to effectively cheat the laws of physics. Instead of traveling through space, the spacecraft moves within a bubble of warped spacetime. This bubble is what allows it to travel vast distances in a shorter amount of time. While warp drives remain theoretical, they spark our imagination. They make us wonder about the vastness of space and the possibilities of interstellar travel. The idea of warp drives continues to inspire scientists and dreamers alike. Could they one day become a reality? Let's explore the science behind this fascinating concept. To understand warp drives, we need to understand space-time. Space-time is a four-dimensional concept. It combines the three dimensions of space: length, width, height, with time. Imagine space-time as a fabric. Objects with mass, like stars and planets, create dents in this fabric. These dents are what we experience as gravity. Gravity is not a force pulling objects together, it's the curvature of space-time caused by mass. This is where warp drives come in. The idea is to manipulate this curvature to our advantage. A warp drive would create a warp bubble around a spacecraft. This bubble would compress space-time in front of the spacecraft and expand it behind. The spacecraft itself would remain stationary within the bubble. Think of it like surfing a wave. The surfer doesn't move through the water as much as they ride the wave itself. Similarly, a warp drive wouldn't propel a spacecraft through space in the conventional sense. It would ride the wave of warped space-time. Albert Einstein's theory of general relativity is crucial to understanding warp drives. This theory, published in 1915, revolutionized our understanding of gravity. It provided the mathematical framework for describing how matter and energy warp spacetime. General relativity allows for the possibility of spacetime distortions. These distortions could theoretically be manipulated to create a warp bubble. Einstein's equations showed that massive objects warp spacetime. However, creating these distortions artificially is a whole other challenge. It would require immense amounts of energy, even more than what's currently available to us. Despite the challenges, general relativity provides a glimmer of hope. It suggests that warp drives are not entirely impossible. They reside in the realm of theoretically possible but remain outside our current technological reach. While warp drives are theoretically possible, many challenges stand in the way of making them a reality. One of the biggest challenges is the energy requirement. Creating a warp bubble would require an enormous amount of energy, more than what our current technology can produce. Another challenge is the type of matter needed. Current theories suggest the need for exotic matter, a hypothetical type of matter with negative mass. This exotic matter would be needed to create the negative energy density required to warp spacetime appropriately. However, exotic matter remains undiscovered. Even if we could overcome these challenges, there are still many unknowns. We don't know how stable a warp bubble would be, or how it would interact with objects in space. There's also the question of how to control a warp drive and navigate through warped spacetime. Despite these challenges, research into warp drives continues. Scientists are exploring different theoretical models and looking for new ways to manipulate spacetime. The development of a warp drive is a long way off, but the pursuit of this technology could lead to breakthroughs in our understanding of the universe. The future of warp drive technology holds the potential to transform humanity's place in the cosmos, opening up new frontiers and redefining our destiny among the stars.